So the first property of logs that we'll talk about in this lesson is product property. So it says that when log base b of m times n equals log base b of m plus log base b of n. Do some examples with this. So we'll condense into a single logarithm. So we have log base b, which is 2, times 7 times 4. 7 times 4 is 28, log base 2 is 28. Base 10 times 25 of 25 times 4 equals log base 10 of 100. M equals 2x, n equals 4x squared. Log base 4 is m times n, 2x times 4x squared. Log base 4 of 8x cubed. Next, we'll expand using the product property. Since 6 is not a prime number, there's a few ways that you can answer this, but we'll break it up into factors of 6. So 2 and 3. This equals log base 10 of 2 plus log base 10 of 3. You could also do log base 3 plus log base 2, and that's still correct. Next we have a log base 7 of 45. We can expand 45 to 5 times 9. And now we have log base 7 of 5 plus log base 7 of 9. Log base 2 of 5x, we can expand to 5 times x. So we can write log base 2 of 5 plus log base 2 of x. These are equal. The next property is quotient property. So log base b of m over n equals log base bm minus log base bn. So here are some practice problems. First, we'll condense the logs into a single rhythm. So we'll go from this form to this form. M is equal to 24, n is equal to 8. So you have log base 3 equal to 24 over 8 equals to log base 3 of 3. M equals 15, n equals 15. Log base 2 of 15 over 15 equals log base 2 of 1. M equals x to the power of 9, n equals x to the power of 2. So log base 4 of x to the power of 9 over x to the power of 2 equals log base 4 of x to the power of 7. Because remember that when we have two exponents being divided by each other with the same base, we just subtract them. So 9 minus 2 equals 7. Next, we'll expand using the quotient property. So we'll go from this form to this form. So to expand this, we'll find multiples of 4. We'll go with a simple multiple of 8. So 8 divided by 2 is equal to 4. So now we can write log base 8 of 8 minus log base 8 of 2. Log base 5 of 1/3. Log base 5, 1 minus log base 5, 3. We have log base 10 m minus log base 10, 7. Next we have the power property of logs. So log base b of m to the power of n equals n times log base b of m. So we have 5 times log base 4 of 2. So n equals 5, b equals 4, and m equals 2. We'll rewrite it in this form. So log base 4 of m to the power of n. Now 2 to the power of 5 is 32, so we can condense this to 32. N equals 7, b equals 2, and m equals x. So we have log base 2 of x to the power of 7. It's log base 10 of 8 to the power of 1/3. Now we raise something to the power of a fraction. We can also write it as a radical. So log base 10 cube root of 8. The cubic root of 8 equals 2, so you can also write this as log base 10 of 2. So now we're expanding, so we're going from this term to this term. So b equals 2, m equals 8, and n equals 7. So n equals 7 times log base b of m. N equals x minus 1, m equals 4, and b equals 10. So when b equals 10, that's just a base 10. So we'll write it as n times 3 times log of 4. We can distribute this 3, so we have 3x minus 3 times log base 10 of 4. We can rewrite as log base 7 of w to the power of 1/2. So now we can rewrite as 1/2 times log base 7 of w. Using the product property, we'll move this 2 over. So we'll write log base 10 of 6 to the power of 2 minus log base 10 of 9. Using the quotient property here, we know log base b, which is log base 10 of m over n. So 6 squared over 9. 6 squared is 36 over 9. So we'll have log, which actually simplifies to 4. So we have log base 10 of 4. Using the product property, we can change this to log 6 squared. And we can use the product property again here to get log 16 to the power of 1/4 plus log 3. 6 squared is 36 minus log 16 to the power of 1/4 is 2 plus log 3. We can use the quotient property to transform this into log 36 over 2 plus log 3. Now we have log 18 plus log 3. We can use the product property to change this to log 18 times 3. 18 times 3 is 54, so our final answer is log 54. So for log base 6 of xyz to the power of 4, we can expand these logarithms using the product property. You have log base 6 x log base 6 y plus log base 6 of z to the power of 4. Again, using the product property, we can change log base 6 of z to the power of 4 to 4 times log base 6 z. We can bring the rest down. For this one, log base 3 times the 4th root of m to the power 5 times n squared. We can change this radical to an exponent. We can move this 1/4 to the front. So now we have 1/4 times log base 3. And then we can use the product property to split this up into addition. And 5 plus log base 3 n squared. We can use the power property again. So 5 times log base 3 m plus 2 log base 3 n. We can distribute this 1/4. So we have 4/5 log base 3 of m plus 1/2 log base